Hello students, in this video we are going to discuss about function. So what is a function? What is a function? Suppose we have two given non-empty sets, okay? For any two non-empty sets A and B, if there exists a rule F by which each element, suppose X, of set A is associated with a unique element Y of set B, then F is called a function. Okay, we have two sets here, suppose set A and set B. Okay, this is set A, okay, and set B. Okay, this is set B. Okay, so let us represent the elements in A as X and elements in B as Y. Okay, so suppose we have a rule under which X is associated with Y. Okay, and the rule is such that Y is equal to f of X, where f of X is equal to X square. Okay, f of X is equal to X square. So here is the function f from set A to set B is given by y is equal to f of X. Okay, here fx is equal to X square. Then suppose A contains 1, 2, 3 and B contains suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9. So let me write it properly. 6, 7, 8 and 9. Okay, this is 9. So according to this rule, under this rule, fx is equal to X square and y is equal to f of X. Then this element 1 of set A must be associated with 1 of set B, because 1 square is equal to 1. Again, as you see, 2 square is equal to 4. That's why this 2 of set A must be associated with 4 of B, and under this rule where f of X is equal to X square, this 3 must be associated with 9, because 3 square is equal to 9. Now here you can see each element of set A associated with unique element of set B. Okay, so same element of A should not be associated with more than 2 elements of set B. Okay, so according to definition, because here you see each element X of set A associated with unique element Y of set B. Okay, so here you see Y is called the image of x, okay, y, or you can say f of x or y is called the image of x, okay, and x is called the pre-image of y, okay, and set A is domain and set B is codomain, okay. So this is the concept of function, okay. Now you can see these two sets A and B, okay. These two sets A and B both are subset of R, that means set of real numbers. A is also subset of R, B is also subset of R, that means these are set of real numbers A and B. That's why this function f is called real valued function, real valued function, okay, because this function from set A to B, where set A and B both are subset of real numbers, set of real numbers, that's why this function is said to be a real valued function, okay. Hope you understood. So function is nothing but a relation, okay. Function is nothing but a relation, but all the relations are not function. So let me define the function in terms of relation, okay. A relation is said to be a function if no two ordered pairs contain the same first component, okay. So suppose we have a relation R, suppose it contains 1 comma 1, 1 comma 2 and 2 comma 3, okay. Now this is not a function, it is not a function, because you see there are two ordered pairs having the same first component, okay. If more than one ordered pair contains the same first component, then it cannot be regarded as function. Suppose we have another relation R which consists, suppose it is Rs, okay, 1 comma 2, 3 comma 4, 5 comma something, suppose 7, okay. So here you see each and every first component are different, okay. So that's why it can be considered as function, okay. So that's why in terms of relation, a function can be defined as a relation is said to be a function if no two ordered pairs contain the same first component, okay. So hope you have understood. Now let us discuss about onto function or surjective function and into function, okay. So what is onto function? Let me explain. Suppose we have a function f from set A to set B. This is suppose set A, set B, okay. From set A to B we have a function, okay. Now you see if each element in the codomain, so if it is a function from A to B, then B is codomain here, it is codomain and it is domain, isn't it? Now if each element in the codomain is an image of some element in domain, that means suppose in domain we have 1 2 3 4, and suppose we have here 6 9, okay, 6 and 9 suppose, and it is a function such that y is equal to f of x, which is equal to suppose thrice x. Okay, then here you see 2 is associated with 6 because 2 3s are 6, and 3 is associated with 9 because 3 3s are 9. Here you see all the elements in the codomain are image of some elements in domain. That's why this type of functions will be called onto function. Okay, this is called onto function. Now you see, let me take the same function from f from a to b. Okay, so here it is domain, this is the codomain. Okay, this is a, this is b, set a, set b. Same function here, fx is equal to thrice x, suppose, sorry, thrice x only, not thrice x square. Okay, so it contains 1 2 3 4, but this contains 5 6 9. Okay, then according to this function, it is fx is equal to thrice x, so 3 2s are 6, then 3 3s are 9. Okay, 3 3s are 9. So here you see these two elements are the images of 2 and 3 in the domain. So here you know, as we know that this is the domain and this is the codomain, isn't it? But here you see the set of this set containing these two elements, which are the images of some elements in domain, is called range of f. This is what, 6 9. Okay, and this set is a proper subset of set b. Okay, because set b contains 5 6 9, and you see this range of the function f, the range of the function f contains 6 and 9, and which is a proper subset of b. Okay, that means all the two elements are in b, and b contains more elements compared to the range. That's why it is a proper subset. Now in this case, this function f is said to be into function. Okay, it is called into function. Hope you have understood the difference between onto function and into. Now let us discuss about one-to-one function and many-to-one function. Okay, so here you see, suppose we have a function f from set a to b. Okay, so let me represent this function in as a mapping. Okay, as mapping. Okay, like this, with the help of mapping. So here this is set a, this is b. Okay, here it is the domain and it is the codomain, domain and codomain. Okay, so now, so this function f and set a contains suppose 1 2 and 3, and it contains suppose 1 2 3 4. Okay, here you see it is such a function, suppose f of x is equal to x plus 1. Okay, x plus 1. Okay, then this 1 in its domain must be associated with 2 of its range. Not range, actually it's codomain. Okay, so because 1 plus 1 is equal to 2, then this 2 must be associated with 3 because 2 plus 1 is equal to 3. Okay, then 3 plus 1 is equal to 4, so 3 must be associated with 4. Okay, so here you see, in this case all the elements in the codomain associated with the elements in the domain, okay, those belongs to range. So those elements 2 3 and 4 belongs to 2, 3 and 4 belongs to the range of this function. Okay, range of f, okay, that is equal to a set containing 2, 3 and 4. Okay, now you see each element in the range has only one image in its domain. Okay, 2 has sorry, not image, pre-image. 2 has one pre-image, that is 1. 3 has only one pre-image, that is 2, and this 4 has only one pre-image, that is 3. Okay, such functions are known as one-to-one function. Okay, because one element of this set is associated with only one element of this set A. Okay, so that's why it is known as one-to-one function. Suppose we have another function, suppose g, from set A to set B. Okay, from set A to set B. Now such that it is such function. So let me draw again one more mapping here for this function. Okay, this is suppose set A and this is suppose set B, and g is such a function. Suppose gx is equal to x square. Okay, and set A contains suppose -1, 0 and 1, and it contains suppose 1, 2 0, 1, 2, 3. Okay, now you see we know that a function cannot have such ordered pairs. Suppose 1 comma 2, then again 1 comma 3, 1 comma 3. Okay, now here you see their first components are same, so they cannot belong to one function. Okay, but such ordered pairs like you see, suppose we have 1 comma 2, then we have 3 comma 2. Okay, such components, such ordered pairs having the same second components can belong to a function. Okay, and those kind of functions, okay, having more than 2 or more ordered pairs having the same second components are known as many to one. Let me show you, let me explain with the help of this here you see mapping. Okay, so this way, if you represent a function this way, in this way, then it is called mapping. Okay, so here you see we know gx is equal to x square, so that's why -1 must be associated with +1, because -1 square gives +1. Okay, and here you see +1 square is also give +1 square is also equal to 1. That's why here you see these two elements, -1 and +1, both are pre-images of 1 in the codomain. So that's why, as it has two pre-images, so that's why this function is called many-to function. This is called many-to function. Okay, such types of functions are called many-to function. Here you see 0 is associated with only 0, but okay, so here this image, that is 1 in its codomain, has two pre-images, that is -1, those are -1 and +1. So such types of functions are called many-to-one function. Okay, so now let us discuss about inverse function. Okay, inverse. So let us discuss about inverse function. Okay, so what is inverse function? Suppose we have a one-to-one function. Suppose function f from A to B be a one-to-one function. Okay, then its inverse function, its inverse function is defined as defined as f inverse from B to A such that f inverse of f of x, okay, is equal to x, or you can say f of f inverse x, f inverse of x is also equal to x. Okay, so then f inverse x is called the inverse function of fx. Okay, let me explain with the help of an example. Suppose we have a function f of x that is equal to, suppose, 5x plus 4. So in order to find the inverse function, so here you see, from the using this condition we can find the inverse function. f of f inverse x, f inverse of x is equal to x. So using this condition we can find the inverse function. Okay, we can find the inverse function. Okay, as you can see, f of x is equal to 5x plus 4. Okay, 5x plus 4. So if you replace this x by f inverse x, because this function is f of f inverse x, so this is f of x. Okay, so both are in the same form, f of f inverse x and f of x. Okay, so when there is x, when there is f of x, then we have got here 5x plus 4. Okay, so let us replace this x here by f inverse of x, then here this x should be also replaced by f inverse of x. Okay, then this implies 5 f inverse of x plus 4 is equal to x, and this implies 5 f inverse of x is equal to x minus 4, and which implies f inverse of x is equal to x minus 4 by 5. So this is the inverse function of the function fx is equal to 5x plus 4. So this is the required inverse function of f. Okay, so here you see, according to this condition, f of f inverse x must be equal to x. Okay, so let me check, is this true or not? Okay, so here you see, let me clear this first. Okay, a little bit. Okay, now you see this function is f of x, which is equal to 5x plus 4. If you find f of f inverse x, okay, then what will happen? So we have got that f inverse, we have got f of here you see f inverse of x is equal to x minus 4 by 5. So this must be f of x minus 4 by 5. So here you see, if f of x in this function fx, you see, if f of x is equal to 5x plus 4, so let us replace this x. If you replace this x by x minus 4 by 5, then you have to replace this x, 5x, here you see 5x is there, so replace this x by this value. Okay, then what you will get, 5x minus 4 by 5 is, here you see, plus 4 again. So what we have done here, as you can see, this f of x, okay, this f of x is equal to 5x plus 4. So we have to find here f of f inverse x, then f inverse x we have already got, that is x minus 4 by 5. So this must be equal to f of x minus 4 by 5. If you see fx is equal to 5x plus 4, then it must be f of x minus 4 by 5 must be equal to 5. Instead of x, there should be x minus 4 by 5 plus 4. Okay, now here 5 cancel, so we have got x minus 4 plus 4. So plus 4 minus 4 gone x. So here you see, as you can see, this function f of f inverse x is equal to x. That's why this condition is satisfied to be an inverse function. Okay, this condition is satisfied. So hope you have understood this, why f inverse of x is an inverse function of fx, because f inverse of fx f of f inverse x, we have got x. Okay, so hope you have understood this, how to find inverse function and what is an inverse function actually. Okay, now let us discuss about even function and odd function. Even and odd function. Okay, so what is odd function, what is even function? Suppose we have a function f from set a to set b, suppose. Okay, so if f of minus x is equal to f of x, then it is even function. It is an even function. Okay, so then it is an even function. Okay, so if f of minus x is equal to minus f of x, then it is odd function. Okay, suppose we have a function f of x is equal to, suppose, x square. Okay, f of x is equal to, suppose, x square. So here you see, in this case, f of minus x will be again minus x square, which is equal to x square. So as you can see, f of x and f of minus x both are equal. F of minus x is equal to here f of x. That's why this function is even. This function is even. Okay, this is even. Now let me take another function. Suppose f of x is equal to x to the power 5. Okay, x to the power 5. Then f of minus x will be equal to minus x to the power 5. As you can see, it is odd power. This power is odd, so that's why this is gonna be equal to minus x to the power 5. Here we have got x to the power 5, and this is, we have got here x minus x to the power 5, not x to the power 5, minus x to the power 5. So here both are not equal. Okay, so if you find here minus f of x, then what you will get? Minus x to the power 5. Yeah, minus x to the power 5. Okay, from this function. Okay, now you see f of minus x is equal to minus f of x. Okay, that's why this is an odd function. Okay, this is an odd function. So that's why you see, if f of minus x is equal to f of x, then it is even function. This is even function. Okay, now you see, if f of minus x is equal to minus f of x, then it is odd function. Okay, so I hope you have understood what is even function and odd function. Okay, In the next video, we are going to discuss about various type of functions. Okay, classification of functions. Here we will discuss about algebraic function, okay, polynomial function, rational function, trigonometric functions, exponential functions, logarithmic functions, sigma function, reciprocal functions, and mode function, inverse trigonometric function, greatest integer function, or you can say floor function, smallest integer function, which is also known as ceiling function, identity function, equal function, constant functions. Okay, so there are various type of functions, so we are going to discuss about those in the next video. Okay, because I don't want to make this video very long, so in the next video also I will show you how to draw a graph of different functions. Okay, so thank you for watching this video.